Good morning, everybody. Today, we have a very interesting talk on hope speech and help speech, something we all worry about, by Ashik Khudabaksh, who is also a very, very interesting person. So Ashik is currently a research scientist at Carnegie Mellon University. Previously, he did both his PhD and postdoc from CMU. And because he's from CMU, he of course knows a lot of you like Sunana and Harsha and Vivek. Also, he mentioned who I don't see in the talk. So he knows quite a bit, quite a few people in MSR India as well as MSR in general, because he has worked previously at MSR Redmond. I think 3 4 years ago with Ran and Paul. So it's MSR is nothing new to Ashik. But what I really wanted to tell you all is Ashik is a poet. He's an established poet. He has already 3 published books on collected volumes on poems written in Bangla. And Ashik is also a composer. He has composed for the New York Theater, and you can imagine like he's such a multi-dimensional talent. So we are all looking forward to listening to your research, and if time permits, probably we will also listen to your poems and songs. So over to you, Ashik.
Thanks, Monojit, for this kind introduction, and thanks a lot for giving me this wonderful opportunity to share our research. So it's a joint work with Shifani Palokodeti and Jaime Carbonell. So I did my PhD and postdoc both from CMU, and I was advised by Jaime. In my PhD, I was working in the intersection of distributed active learning and game theory, and in my postdoc, we moved to working on in the intersection of low resource NLP, computational social science, and AI for social good. Currently, I'm a project scientist at CMU, and I'm working with Tom Mitchell in the same area of low resource NLP and computational social science. So I would like to start with one of my favorite poems by a Polish Nobel laureate Wisława Szymborska. The title of the poem is The Courtesy of the Blind, and the theme of the poem is the main protagonist in the poem is a poet who visits a blind school for a reading event. And when she opens the first page of her own book, she notices that in the first poem, she has mentioned a color. And then she moves to the next page and she notices that there is a shape. And as she keeps flipping on page after page, she notices that there is a texture, and soon she realizes that she hasn't written a single poem that her visually challenged audience can appreciate in its entirety. The 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 takeaway message from that poem for me was the first step towards understanding or creating an inclusive environment is to be aware of the disadvantaged group's existence. And no wonder why terms like inclusion, fairness, representation, bias are very important terms in modern AI systems. So the first part of our this talk, we focus on the problem of including minorities in discussion about them. And when we say minority, it could be ethnic minority, it could be religious minority, political minority, minority along the gender and health spectrum, and maybe intellectual minority, and the list goes on. But we particularly focus on the Rohingyas. They are an ethnic minority in Myanmar and stateless since 1982. So this is the map of Myanmar, and the shaded region is Rakhine State, where they usually used to live. In the last 10 years, more than 700K people were rendered homeless, and major ethics organizations reported brutal state-sponsored violence against them. And Myanmar, the alleged perpetrators, denied any such ethnic cleansing effort. So our work is not about the citizenship rights of the Rohingyas or about Myanmar's alleged role. Rather, we are interested in what we call this as a 21st century problem, migrant crisis in the era of internet, where suddenly a marginalized community is thrust into global discussion. A lot of people are forming very quick opinion on them, but maybe they have very sparse presence in sparse online presence to defend themselves. And this sparse presence can stem from a language barrier. Maybe the discussion is happening in a global language in which they are not that proficient at. It could be a lack of internet access, or it could be plain and simple. They are too busy to survive, so they don't have time to check what kind of online hates are being perpetrated against them. Now, the online world can be very harsh if you cannot defend yourself. So here are some of the example comments that we found in our data set about the Rohingyas. Um, if we look at the phrases like Rohingyas are and draw a word cloud of the token that follows this phrase, we see that a lot of people actually think that they are illegals, they are terrorists. And if we present a word cloud visualization of the tokens following the phrase send them to, then most alarmingly, we see that hell is also a suggested place that online users think they should be sent to. So the adverse effect of online hate is not only it's twofold. First is users exposed to hateful content targeting a minority, they may form prejudice. And the second thing is the online hate may not remain always confined within the online world. It may trigger offline violence, causing physical harm. So the research question that we were interested in is how can AI help a disenfranchised minority? So a typical approach is finding hateful contents and blocking the negatives. So there is a broad literature in hate speech detection. What we propose is how about amplifying the positives? And we call this help speech, aka voice for the voiceless. So we are primarily interested in the role of AI in championing or supporting a disenfranchised minority. When we say amplifying the positives, we in our paper we do not specify how to amplify certain content. We are more concerned about how to detect the positives, and amplification is something that is left for later research. So help speech is essentially a nuanced classifier that automatically detects comments supporting the Rohingyas. It could be about like seeking organizational help. It could be condemning the alleged oppressor. It could be expressing empathy. It could be vocalizing for the right for the Rohingyas, and so on. So we focused on social media platform YouTube, particularly because YouTube is very popular in Southeast Asia. In fact, in India, I think it's the #1 social media platform right now in terms of its user base. And our data set is comments relevant to YouTube videos, comments on YouTube videos relevant to the Rohingya refugee crisis. So we constructed a corpus of 263K comments from nearly 5,000 videos, and the comments are posted by more than 100K users. So our dataset is text dataset. Before I describe some of the challenges of our project, I want to emphasize a subtle point, that is help speech is not absence of hate speech. So if a comment is help speech, it definitely implies that it is not hate speech, but the inverse is not true. Take this example comment: India is already overpopulated. We do not have enough resource for the Rohingyas. This is definitely not hate speech. And at the same time, it is not helping the Rohingya community either. So help speech and hate speech, uh, those two things are actually serve two different purposes to make the life for the disenfranchised minorities in the online world safer in two different ways. Now, I described the first few linguistic challenges that we faced in this work. One is the Indian subcontinent. I mean, they have huge linguistic diversity. India alone has 22 languages recognized by its constitution. One advantage of looking at YouTube comments is it provides a corpus with topical focus, but at the same time, we have the challenge of how to extract a monolingual corpus from a multilingual dataset. Then the second challenge is since this geographic region, most of the people are speak English as their second language. There is a broad range of English proficiency levels. So we saw in the data set a lot of grammar and spelling disfluencies, phonetic spelling errors. For example, it's a bit hurting that all the developed countries are selfish. In this comment, selfish is most likely selfish, but the true, we don't know if hurting is hurting or heartening, and depending on what it was originally intended to be, the meaning of the comment might completely, the sentiment of the comment might completely change. So these are the two linguistic challenges that we faced in our work. In machine learning challenges, the first thing is for any good classification construction, we would need an effective training set which is balanced, which is roughly having same number of examples from the two classes. In this case, we are dealing with a binary classification task. And the data set has to be diverse enough so that when we train the classifier and if we run it in the wild performance is good. Now, positives are rare in this case because the vast majority of the comments are against the Rohingya community. And if we randomly sample comments, we found that roughly 10% of these are voice for the voiceless or help speech. And we need to find enough positives for better balance. And also, since help speech has a nuanced definition, then the sample should span all positive and negative subclasses. So in short, it becomes like a circular problem. We need to find positives to construct a classifier to discover more positives. A little bit of background on word embeddings before we describe how we tackle our linguistic challenges. Word embeddings is basically a continuous representation of words in high dimensional space. And words with similar meaning are typically placed near to each other in the resulting embedding. And the polyglot skipgram word embeddings, they are skipgram embeddings trained on a single multilingual corpus. So now I will describe a very useful result that we found in one of our works is polyglot embeddings are very useful for identifying languages. So if we train a polyglot skipgram embedding on a multilingual corpus and then obtain word embeddings, and then for each document, we just average the normalized word embedding to create a document embedding. Once we cluster them, we find that the cluster shows very clear, crisp monolingual separation. For example, in the right side, we have 21 European languages from the European Europal dataset. And we see that once we clustered them, we see very precise 21 clusters. And in the left side, we have YouTube comments from Odia TV, that's a regional YouTube news network in India. And there we see that the boundaries are not that clearly separated, but we can still obtain very good linguistic separation. Now, one advantage of this technique is the clustering is largely unsupervised. Like once the clustering is done, for each cluster, we have to label its language by just randomly sampling, say, 10 comments per cluster. So it's extremely annotation efficient to figure out the language label of each of the individual clusters. And once we have language label for the cluster, whenever we have a new document, all that we have to find out that what is the nearest, what is the cluster it belongs to, and then whatever is the language label for the cluster, we just assign the language label to the document. So it's a very annotation efficient method, and extremely simple, but very powerful, because some of the languages that we deal in India, they don't have very good support in commercial solutions. So we can actually use this technique to obtain language labels for those kind of languages. Rohingya corpus, apart from English, we identified Burmese, German, Bengali, uh, French, Arabic, Hindi, Malay in our non-English corpus. And for the rest of our analysis, we focus on the English corpus that we extracted using our polyglot embedding-based language identifier tool. So now we come to our second challenge, how to find positives. So we used multiple active learning strategies to boost the number of positives and construct a balanced set. We also used a novel active sampling technique to find a diverse set of positives. And I'll describe them one by one. So time for a little background. So active learning is a well-known technique to efficiently accumulate labeled data. The key philosophy is all data points are not equally useful. So if we involve the learner to acquire which data points we need labels for, then the process can be expedited and it can be more efficient, because the learner is selecting that these are the data points that I'm not very sure of, or these are the data points that I'm encountering more often. So since the learner is involved in the whole process, that's why we call it active learning. There are known sampling strategies. The most standard strategy is uncertainty sampling. Then there are some other strategies like density-based sampling, one-sided extreme or certainty sampling, and so on. A typical active pipeline, learning pipeline looks like this. We start with a seed set of example. We train a model. We use the model to request labels from unlabeled pool of data using a sampling strategy. And we expand the data set with newly acquired labels. And then this process keeps going on until some kind of halting criteria is met. And some standard halting criteria is maybe we reach a certain performance threshold in our classifier, trained classifier, or it could also be that we run out of labeling budget, or we run out of unlabeled pool of data. So that's the basic pipeline of active learning. And I specifically mentioned labels in the step 3 is because typical active learning pipeline, we request one label at each iteration, but there is a theoretical result in New RIPS 2013, which shows that even if we do bulk active learning, where we are just requesting labels for a batch of examples, we can still don't lose much performance. And there are some theoretical results on that. So now I focus on the first step, how to create a seed set. So recall that help speech has a nuanced definition, and our goal is to obtain a seed set containing diverse set of examples satisfying all subclasses. So what we do is we start with an example for each subclass, and we find nearest neighbors in the comment embedding space. So for example, if it's about organizational help, an example comment could be UN should help the Rohingyas. If it's about advocating for the rights, it could be Rohingyas should get Myanmar citizenship. It could be value the humanity, they are migrating for lives, not for luxury, when it comes down to expressing empathy, and so on. So the reason the top two comments are written in blue font is because these two comments are not coming from the original data set. So we suggested the annotators that if by quickly skimming through a small part of the data set, you don't find any comment that satisfies any of these criteria, you can write your own short example comment that satisfies this particular condition. And this is particularly very useful in the case of rare classes, because in rare positives, if we don't have an example comment that satisfies this particular subclass criteria, the annotators can actually write their own example, and then we can perform nearest neighbor sampling and then start finding comments from the actual dataset. In the case of negatives, we did not have the problem of finding examples from the dataset. So if it's call for violence, then an example comment is Pakistan, please nuke Myanmar Buddhists, supporting the alleged oppressor, well done Myanmar. And this particular criteria was very interesting. We call it whataboutism. So we noticed that uh, a typical tendency in online discussion is whenever there is one disadvantaged community, some commenters will say, what about some other disadvantaged community? As if the suffering of one disadvantaged community can somehow be explained or justified by the suffering of some other disadvantaged community. I would also like to mention that in the call for violence, here Pakistan please nuke Myanmar Buddhists, the violence is being perpetrated against the alleged oppressor. In our help speech definition, violence against the alleged oppressor is also not allowed. So this is still an example of negative help speech. So the advantages for our active sampling is, as I already mentioned, examples need not to come from the data set, which is particularly very useful for rare classes. And since we used subword information in obtaining our document embeddings, it's very robust to spelling variations and errors, which is useful in noisy social media setting. And because we are starting from each subclass, we are coming up with an example comment, and then we are finding the nearest neighbors. So we are or implicitly obtaining better subclass representations, because from each subclass, we are just expanding using nearest neighbor sampling. Now we focus on the step 3 of our active learning pipeline, is use the model to request labels from the unlabeled pool using a sampling strategy. So as I already mentioned, the typical strategy in active learning is uncertainty sampling, where the learner requests labels for which the classifier is most unsure about. However, for rare class problems, certainty sampling is a technique where the learner requests labels for which the classifier is most sure about. So when the minority class is the positive and you want to jack up the number of positives, so the minority class certainty sampling could be an effective way to jack up the number of positives. And this has been previously used to improve class imbalance in other short document domains. And this was my internship project with Paul and Ryan. And in this paper, we use a combination of both uncertainty sampling and certainty sampling. So here a quick look at our overall scheme. So we first start with a small set of example comments. In our help speech definition, we have 6 subclasses for positives and 5 subclasses for negative. So we start with 6 positives and 5 negatives. Then we perform nearest neighbor active sampling. We end up with 38 positive and 273 negatives. Then we perform a round of random sampling to improve diversity. And as you can see that there is still a huge gap between the number of positives and negatives. In step 4, we perform certainty sampling to tackle class imbalance. And we breach the gap between the positives and the negatives. And we finally end with a step of uncertainty sampling. And at the end of this step, we end up with roughly same number of positives and negatives. So our overall data set is finally balanced. We trained a lexical baseline, a SVM with unigram, bigram, and trigram as features. And we see that the F1 score steadily increases as we keep obtaining more data and also bridging the class imbalance. So our final F1 score is close to 76%, and it's very easy to squeeze more performance out of the classifier. So instead of just SVM trained with n-grams as features, if we use SVM trained with n-grams plus we consider the embeddings as feature, we see that there is a performance boost that we obtain. But our main goal is not to squeeze as much performance as we can from the train and test split. We are more interested in observing what happens in the wild. So in the wild means we ran our classifier on the part of the data that belongs neither to the train nor to the test. So it's data, it's completely out of our train test split. And when we run our help speech classifier, we obtain top 100 comments predicted as help speech. And when we do human annotation, we find that 88 of them were marked as positives by our human annotators. Recall that random sampling just yielded 10.77% positives. So this indicates that our classifier can substantially reduce web moderation. We were also interested in seeing if the positives that we find in the wild, if they represent each of the subclasses well. And we find that for each of the subclasses for help speech, we find more than one comments satisfying that particular subclass. So our obtained data set, our obtained comments are diverse also. Now, I'd like to pause a little bit and let you read this comment. This is an example positive we found in the wild. So as we see that the word citizenship, ethnic cleansing, even the word help, these are spelled incorrectly. And there are a lot of grammar disfluency also in this comment. So we suspect this is most likely written by a Rohingya user. And the fact that our classifier could find this comment in the wild, it indicates that our method holds promise in performing well in the wild, dealing with this kind of grammar and spelling disfluencies. So this is another example comment that made us to think about something else. For example, this comment, which says that the Myanmar government is really kind of like animals, our annotators mark it as positive. And we asked them why. And the explanation was, assuming that the atrocities, alleged atrocities, are real, some measured expression of anger is expected. Now, the question is where to draw the line. Is this still help speech because it's containing hate speech about the alleged oppressor? And the more important question is who gets to draw it? So this kind of examples actually made us aware of the challenges, the typical challenges also we find in hate speech detection, because how to give very thorough and crisp and precise guidelines to the annotators to describe what is help speech and what is not is a very challenging problem. And this one comment actually made us aware of this challenge. The takeaways from the first part of our project is we looked into a different aspect of web vulnerability of marginalized communities, and that's the sparsity of pro-minority voices championing their cause. And we looked into AI's possible role in addressing this. We also emphasized that hate speech and help speech, they serve two different goals, and embedding best methods hold promise in tackling noisy social media data. We also found that combining active sampling and active learning, it can be an effective strategy to address class imbalance. Now, this idea of surfacing positive content, what could be some of its broader applicability? So we focused on another domain where we feel that just simply blocking the hate will not be an enough strategy. So we focused on heated online discussions between nuclear adversaries, India and Pakistan. Again, our choice of platform was YouTube. And the research question this time is like when the civilians of two nuclear adversaries are at at the brink of war and people are engaging in heated political discussion, can AI help in detecting peace-seeking, hostility diffusing content? Um, a quick background of the conflict that we looked into. So we looked into a short span of like 4 weeks in starting from 14 Feb 2019, and that lasted for about a month. On 14th Feb, there was a terror attack that happened in Kashmir, and a Pakistan-based militant organization claimed responsibility. Soon after that, a lot of diplomatic escalations started happening, and then on 26th Feb, Indian government claimed that they performed an airstrike in India in Pakistan, and which claimed massive casualties. And on 27th Feb, uh, an Indian pilot got captured by Pakistan. And in between the 26th, 27th, and 20th Feb, in those 3 days, the two countries came precariously close to declaring full-fledged war. Up until on 1st March, the Pakistan Prime Minister Imran Khan released the Indian pilot uh, as a peace gesture, and the immediate tension between the two countries were somewhat subdued after that, but still it's a very tense political situation between these two countries. And if we look at the history, their acrimonious past dates back from like 15th August 1947 to till today. And Kashmir is a disputed region since the inception of the two countries. There have been 4 full-blown wars and many skirmishes, and both countries are nuclear powers. And a recent study reported that should there be a full-blown war between the two countries, uh, there could be as many as like 100 million deaths. So again, in this work, we focused on nearly 2 million comments on videos relevant to this Pulwama terror attack. And when we used our polyglot embedding based language identifier, we could separate 1 million English comments. So you can see from this visualization that there are 3 clusters, and which means that we just needed to annotate 30 comments, 10 per cluster, to process these 2.04 million comments and obtain monolingual separation. So again, this is very annotation efficient. In terms of the English written by non-native speakers, we had very similar challenges as our Rohingya project. This is one example comment: "Thank you, Pakusta, for humanity, no war." So you can see a lot of spelling disfluency. And 32% of the times, liar was misspelled as lier. So there are a lot of spelling errors in the data set. So similar to help speech, we define a new task of detecting hope speech, which is a nuance classifier detecting hostility diffusing content. It could be peace seeking. Suppose, for example, we want peace, or it could talk about humanitarian cost of war. Peace is better than war, as the price of war is death of innocent peoples. And it could be appreciation for neighbor. I'm from Pakistan. I love India and Indian people. And it can go on. There are many more subclasses, which I'm not describing here. So using similar techniques as our help speech classifier, we built a hope speech classifier, and we were again interested in looking at the performance in the wild. So when we do random sampling, we only obtain 2.5% hope speech. So again, this is a rare class, rare positive mining task. Our classifier in the wild yields 84.7% hope speech that are evaluated by human. So again, we obtain substantial improvement in web moderation. If we look at the different uh, subclass representation, we see that in the wild we also find positives belonging to different of the different subclasses in our hope speech definition. There are some example hope speech we found in the wild. The particularly interesting one is this one: in peace, sons bury their fathers; in war, fathers bury their son. This is originally by Herodotus some 2500 years back, and it's being reproduced on YouTube comments. Tells us that in the last 2500 years, we still, as like a humanity, we still haven't been able to fully understand the futility of war. Um, we conducted a, a, a study of how the pro-peace and pro-war intent evolved over these 4 weeks of time. And for this, we created a comprehensive set of intent phrases, and we counted the number of comments normalized by the total number of comments posted for that particular day to evaluate how the peace-seeking and the war-seeking stance evolved over time. And surprisingly, what we found in this analysis is when the threats of war became imminent, common people actually tend to gravitate towards peace. So this was a very interesting social science result that we found in this work, that when the two countries became precariously close to declaring a war, we can see also there is a huge spike in the number of comments also posted during that time. So most likely the saner voices, the voices that don't think that war is a good solution, they participated heavily in the discussion, expressing that war is not a good idea. So this was a very interesting social science result that we obtained in this paper. Now I move to the final part of this talk. So for people who don't understand Hindi, the top comment, "मैं अमन चाहता हूँ, खुदा के वास्ते जंग नहीं," would not make much of a sense. However, like "I love India, I am Pakistani, peace, peace, peace," this we understand is a peace-seeking conciliatory comment. Now, the fun part of the whole thing is this is the same comment. So I love India, I am Pakistani, मैं अमन चाहता हूँ खुदा के वास्ते जंग नहीं, peace, peace, peace. So this phenomena is known as code switching, which is a seamless transition of languages within the same document boundary. So typically code switching is looked at as an obstacle to downstream analysis. And there are many important work on switch point detection, token level language detection. Uh, However, in this comment, we find an interesting observation that a short document is likely to express a consistent sentiment. And there could be interesting sentiment parallelism. So although I don't understand what "मैं अमन चाहता हूँ खुदा के वास्ते जंग नहीं" exactly means, but since it's a part of a peace-seeking comment, I can have an educated guess that maybe "मैं अमन चाहता हूँ खुदा के वास्ते जंग नहीं" also means something peaceful. So the research question is, can we harness code switching to perform cross-lingual sampling for social good? Uh, Consider we have a document level sampler of code switch comments, and we also have a precise word level language identifier. So using this, we can actually sample code switch documents that exhibit hope speech. We first use the sampler to obtain a code switched comment, and then we run the hope speech classifier, and using both, we can actually find code switch documents exhibiting hope speech. Once we have this code mixed comment, we can extract the Hindi part of the code switched comment, and we can perform nearest neighbor sampling of the extracted Hindi part in the Hindi region. So let's start with a simple example, and then it will become more clear. So before I start, our language identification method that we presented based on polyglot word embedding, it also works well at the word level. So we can use it to sample documents with substantial code switching. So suppose this is the comment that we were looking at. I love India and Pakistani. मैं अमन चाहता हूँ खुदा के वास्ते जंग नहीं, peace, peace, peace. So when we run our token level Hindi extractor, so the extracted Hindi is मैं अमन चाहता हूँ खुदा के जंग नहीं. So it makes a mistake. It thinks vaste is west, but nonetheless, in spite of this noisy extraction, when we perform nearest neighbor sampling of this noisily extracted Hindi comment, we find that a comment purely written in Hindi as a nearest neighbor, which translates to I am a Rajput. I never want fight between the two countries. We were one country before the partition. Only a handful of extremists want bloodshed. So visually, if we look at this diagram, the blue region represents comments in English. The red represents comments in Romanized Hindi, that is Hindi written in Roman script. The code mixed region is the black region between the two language clusters. And we can see that the magenta triangles are the code mixed hope speech. But once we extract the Hindi out of the code mixed hope speech and we perform nearest neighbor sampling, we see that the nearest neighbors are all in the Hindi region outside the code mixed region, right? So just using the code mixing this phenomena as a bridge, we obtain a tenfold sampling performance improvement. So if we just randomly sample in the Hindi region, we will get around like 2% hope speech. And with this sampling method, we get like 23%, and which just comes for free just by utilizing code mixing and the intuition that if there is a short document written in two different languages, chances are pretty high whatever is the sentiment expressed in language A will be very similar to the sentiment expressed in language B. Now, when we work with a fast moving crisis like the current COVID-19 crisis, we may not have a content classifier even in English. So if we are heavily constrained with a situation that we don't even have a content classifier, but we have some example English comments, can we perform cross-lingual sampling to obtain similar Hindi comments using this phenomena? So turns out that with using a clever trick, this can be achieved. So suppose we start with an English comment, and the comment is, we should maintain social distancing. In step 2, we try to find nearest code mix neighbor. And when we perform the nearest neighbor sampling with the English comment, we disable the Hindi part. So we should maintain social distancing is actually matched with obeying social distance is important. We completely disregard the Hindi part while we are computing the nearest neighbor in this step. In the next step, we now focus on the Hindi part. घर पे रहो भाई लोगो बाहर मत जाओ. And then we try to find what are some similar comments in the Hindi region that is similar to this घर पे रहो भाई लोगो बाहर मत जाओ. And when we do nearest Hindi comment with English disabled and Hindi enabled, we find something like जून बना के बाहर मत घूमो फिरो. So effectively, this means like we are almost performing something like a chain database query where the English component and the Hindi component are two keys and which are acting as the bridge for us to move from the English example comment to find something equivalent in the Hindi region. So once we did this experiment on a COVID dataset, we found that we, with our sampling technique, we find 5 times more positives than the random baseline. And these comments express compliance to CDC guidelines. I would like to say one more thing that in low resource language setting, I mean, typically linguistic resources focus on economic forces. like whichever language has more, the importance of a certain language is often decided by economic forces. But during a pandemic, the linguistic resource demand might get recalibrated, and spaces or regions that are very densely populated, whatever language they mainly speak, we would need rapid resources for those kind of languages. So by harnessing code switching in this way, we can actually perform cross-lingual sampling and transfer resources in world languages to its low resource counterparts. Uh, this is actually a short digression. We had a discussion with Monojit 2 days back about our paper, which is not exactly related to all this work that I was describing. But he said like I should include just one slide to describe it. So there has been a recent AMNLP paper where BERT was used as a knowledge base. So BERT has its mask word prediction model, right? So what they did was they will say that Dante was born in Mask, and then BERT will give solutions like number of certain words ranked by probability, and it was found that the top predicted word is Florence in this case. And again, they asked BERT a mask query. Theory of relativity was proposed by Mask, so BERT can correctly predict Einstein. So in this paper, they explored the capability of BERT to be used as a knowledge base. We took a leaf out of this publication and went one step ahead and wanted to see that can we use fine-tuned language models for polling tasks. Like if we have a corpus of Indian election and we fine-tune BERT, can we ask like vote for Mask or Mask will win, then see what kind of political entities BERT predict with what probability. So that could be useful for polling. Then we can also track evolving national priorities. Suppose there is a mask query, the biggest problem of India is mask. Then what does BERT predict? Does it predict unemployment, poverty, or does it predict Pakistan and Kashmir, depending on what time range we are interested in? And also, we can track perception of religious communities like Hindus are masked and Muslims are masked. And we can track what kind of words are predicted by BERT when we ask this kind of religious perception question. So the main takeaways of this paper was asking this kind of masked query can be an effective method to obtain coarse-grained insights. And we also find that there is some amount of religious polarization in India. So there is a lot of negative perception around both religions. So, so finally, I'm at the last slide. In this work, we talked about framework novelty, where instead of blocking the hate, we focus on amplifying the positives. We found that polyglot embedding-based language identification is very useful, not in the Rohingya, just the Rohingya project or the India-Pakistan project. In the 2019 Indian general election, we dealt with 12 regional Indian languages, and it was very useful. We found active sampling is an effective technique both in Rohingya refugee crisis and India-Pakistan conflict. And finally, we found code switching can be harnessed for social good. In all this work, while we were writing the papers, we were pleasantly surprised by the rich body of work done by the Melange group in the, MSR India, and it actually made our work so much easier because whenever we have to say like there is a lot of code switching in Indian languages, we can just cite a relevant paper, or a lot of the content in social media is Romanized, use Romanized Hindi or Romanized regional languages. We have a paper to cite, so it was very useful for our research to establish why and how the problems are important. Finally, this work was done with Jaime Carbonell. Jaime was my PhD advisor, postdoc mentor, and I have been working with him for the last 9 years. when we were working on all these projects, Jaime was going through um, a very serious health struggle. Nonetheless, it was I cherish every single moment that I got a chance to work with him. And these projects were very close to his heart, and I would like to dedicate this work to him. Thank you.
Thank you, Ashik. It was a really wonderful talk, and I'm sure there will be many questions. So, people who have questions, please raise your hand and we can go in order. And maybe I can start with a quick question. So, all the comments that you showed, except for one or two, were long. And when there are long comments, so specifically the one you said, most probably a Rohingya person wrote, where there are lots of spelling errors and everything, but since it was a very long comment, I would assume that there is enough evidence of it being a help speech because of words like stop genocide and things which are written properly. So I was wondering, what is the accuracy of this system? I mean, do you have a feel for it for shorter comments? Because that's where we find most of the systems fail, and it becomes very hard to build something robust, like let's say 5-word comments or 10 or less than 10-word comments. Did you do some such study?
We did not do uh, like thorough analysis on, like, I don't have a number for you, but many of the comments were actually on the shorter side, and there was a good mix. And actually, one of the reasons YouTube is very an interesting medium in this case, because for Twitter you have an upper bound, right? For YouTube we don't have any upper bound of the length of the comment, so there was a huge variance in the comment length, and I think the number is presented in the paper. So there were a lot of short comments and there were many long comments as well, and I think the classifier performed reasonably well across both.
That's great to know. I will check it out. The other one which I found really intriguing was this Herodotus comment that you have, which was very hard even for me as a human to parse. I had to read it a couple of times to get, okay, this is what it is saying, and therefore it's a help speech. So have you tried, swapping the clauses? So suppose we had, I mean, I'm sure probably you didn't try, but if we swap the clauses, like in war, I put what happens in peace and vice versa. So it just changes the polarity of the comment in that sense. Would it still, would the system still detect it as, a help speech? I mean, something I thought would be interesting to do.
We have tried, I mean, like, we did not try is explicitly swapping, but we noticed that suppose someone is saying that war is not a solution, peace is the solution, and then there is someone, another comment, war is the only solution. This kind of juxtaposition of just war and peace interchanging between them. And since we are using n-grams, most of the cases, I think it correctly classified. But yeah, there were few cases where it fails. So I think if we want to do a more robust uh, classifier using some this kind of adversarial examples, and training the classifier could be an interesting direction.
Yeah. I mean, it was more like my NLP mind triggering up, but otherwise, yeah, those might be corner cases anyway. Anirudh, do you have a question?
Yeah, hi. So I had a question about the part where you mentioned about the nearest neighbor search for finding more examples, right?
Yeah.
So one thing that wasn't clear to me was like, uh, are you performing the nearest neighbor search to find comments and then using that in the active learning, or how is it? Because wouldn't you get a lot of negative examples also when you do that?
Yes. So, like, we have an example comment, and then we want to find, we want to expand that particular subclass, right? Suppose Rohingyas should get Myanmar citizenship. And then when we do nearest neighbor sampling in the comment embedding space, there will be some cases where we will also find examples like Rohingyas should not get Myanmar citizenship because it almost identically matches the seed comment, but it completely changes the polarity. So the reason this nearest neighbor sampling was useful because we have a human in the loop. So the nearest neighbors sampling is allowing us to find comments that are structurally or maybe likely semantically similar to the seed comment, but then the human in the loop is making sure that the comments are labeled accordingly. Does that answer your question?
Yeah. I just had one more thing. So these plots of these embeddings, they are T-SNE plots.
Yes.
Oh,
Yeah.
okay. Thank you.
Any other question?
Yeah, so I have a question. Hi.
Go ahead, Soma.
Yeah, yeah. Yeah, so I really like the last comment that you made in the that first project that I mean that was the first question that I had, that what happens if hope speech turns into a hate speech by looking at the other group, whether you call it majority or whatever, and I mean, perpetuating some sort of hatred for that group itself, and who is to draw the line. The second part is whether, I mean, socially or politically, we don't know. But how do we train annotators? I mean, what are the whether you have made certain observations about that how do you train annotators at least to make sure that this doesn't happen, right? The whole the fact that, I mean, it's a fantastic thing to think that I mean, you are doing hope speech in an era of hate speech, which is something that I really liked. I mean, I was getting a little bit sleepy because I just woke up, but your kind of I mean, presentation got motivated me to wake up completely. So yeah, that was my question actually. So whether you have found certain other things as well, how to train annotators.
So what we did, like when we it's we presented the results in very details in the papers. So we tried to address bias in like various levels. So for example, a large part of our work focused on obtaining related search queries from Google Trends data, and there is a result that if there are two entities, you tend to place the entity ahead of the pair, whoever you feel closer to. Like, for example, if a Republican posts a search query, he will say Trump Hillary election, and a Democrat is likely to say Hillary Trump election. So, similarly, when we were finding Google Trends result, when we were focusing on Indian Google queries, we always put India ahead of Pakistan when there is a search query where we have India and Pakistan in the pair. And whenever our geographic location was Pakistan, we swapped that and made it Pakistan India conflict or something like that. So even in that level, we wanted to reduce bias. When we worked with the annotators, unfortunately, we did not have a Pakistani annotator. So both annotators were from India. So there, since the time period of this conflict was extremely close to Indian general election, we removed any comment during the while constructing the training set that contains the name of the Indian Prime Minister, and also for consistency, we also removed the name of Pakistani Prime Minister directly, so that the political affiliation bias of the annotators do not affect or influence the data. So there also we find that it's a very challenging task to construct a data set where there are like so much uh, like it's so politically charged, right? So we wanted to eliminate certain things like that to make sure that biases are addressed. But it's a very interesting direction where future
Right.
research can go.
Exactly. Exactly. Okay. Great to know. Thank you.
Thank
Okay, I think we are out of time, but yeah, Ashik, it was a really wonderful talk. Again, thank you, and thanks everybody for joining. Nadeem
you.
has recorded the talk, so we will put it on ResNet. And those who, especially from Redmond, people who wanted to join and couldn't, they can watch the talk offline. Okay,
And thanks a
thank you
lot
all.
for giving me this wonderful opportunity. Thank you.
Thank you, Ashik.
Thank you.
Thanks.
Bye bye.